Good morning, class. Hope everybody is doing well. Today we are going to look at logarithms. We are going to use the behaviorist theorem to learn logarithm. We integrate it with the understanding of logarithm. Then we will look at what the behaviorist theory is all about. When we talk of the behaviorist theorem, it's a learning theorem that suggests that all behaviors that are learned is as a result of the interactions of the environment. Then it deals more specifically with conditioning, through conditioning. And then the theorem also emphasizes more on repetitions, feedback, stimuli, and then reinforcement. So let's put something down so that you can understand more. More specifically to look at this. So we said the behavioral theory is a learning theory that suggests all behaviors are learned through the interactions with the environment, more specifically through conditioning. Good. So we said that it emphasizes on positive stimuli. So it emphasizes on the following: feedback, repetitions, reinforcement, and then positive stimuli. So having understood what the behaviorist theorem is, we will now go ahead to look at the logarithm, the topic itself. Logarithms. So in the course of the learning or the class, we will be using the following. You will give us feedback and we will repeat some of the examples more, and then we will use reinforcement, and then of course we will use the positive stimuli to help better understand the topic logarithm. So what do you mean by logarithm? We are saying that if you have mathematically you have something like this, logarithm of b to the base a, logarithm of b to the base a. This is in a log form. So we simply say that any number, any logarithm, say b to the base A has to raise to a particular number to give you a result. So for instance, we could have something like this. We could have something like this. So we will now have A exponent C will give us B. A exponent C will give us B. So we say that this is in 8 logarithm form, and then this is in 8 indices form. This is logarithm form, and then this is indices form. What it means is that the number A to the exponent of C has to give you B. The result has to be B. So if you understand, for instance, you have something like this, log 32 base 2, what will be the result? What will be the answer? So, because we do not know what the answer is, we could say that we let log 32 base 2 equals to a certain variable x. Then we simply say that we let 2 raised to the power x, which will give us 32, as we did here. This was the logarithm. Then we brought it here, just like this. Then this was the base. We brought it here, and then the c, which was here. We brought the s as here. So we have to manipulate and make the base the same. So we ask ourselves, the base here is 2 raised to the power x. So which number raised 2 raised to which number will give us 32? So we could simply say that we have 2x here will give us 2 exponent 5. 2 exponent 5. So we say that, let's see this, this, and that. So these are this 4, 8, 16, and then 32. So because the bases are the same, we could simply say that x is equal to 5. So we could now have that the log of 32 base of 2 is equal to 5 in the logarithm form. So in indices form, we will now have 2 exponent 5 to give us 32. Right? So let's look at another example. Let's look at another example. We will have log of 2, log of 64 base 2. Log of 64 base 2. So because we do not know, we can say that we let log of 64 base 2 equals to n. How do we manipulate? So we say that 2 exponent n will give us 64. So we look at 2 exponent 1 will give us 64. So we say that 2 exponent n will give us 2 exponent 6. Right. So we can now say that n is equal to what? 6. And then we could simply say that logarithm of 64 base 2 is equal to 6. Right. Is equal to 6. Any question here? Any question here? If there is none, then let's move ahead. We understand what the behaviorist theory is. We understand the logarithm, how to find it. We look at the laws of logarithm. Let's look at laws of logarithm. Laws of logarithm. So we have the first law as we have something like this: log of ax plus log of ay. This will give you log of a, log of a, log of x, y base a, log of x, y base a. What it says is that anytime you have two logs with the same basis adding together, then you multiply the logarithm. You multiply the logarithm. So for instance, you have the log of 2 base 3 adding log of 4 base 3. what it simply says is that because the bases are the same, you multiply the logarithm. So we now have log of 3 to multiply by 4, which will give us log of 3 to multiply by 4 is 8. Log of 8 base 3. Log of 8 base 3. So this is what the first law is talking about. When two logs are added with the same base, you multiply the logarithm. Let's move ahead to look at the other law. I believe I can play here. The other logarithm in the law 2 say that if you have log of x divided y with the base a, then it will give us log of x base a minus log of y base of a. So when two logs with the same base are divided, then you simply subtract. You subtract them. So let's have an example. Have log of 2, 6 divided by 3. This will simply give us log of 6 base 2 minus log of 3 base of 2. So this will give us log of 6 minus 3 base of 2. Base of 2. So 6 minus 3 will give us 3. So we have log of 3 base of 2. Log of 3 base of 2. So anytime two logs are divided, you will simply subtract them. They will take note when they have the same basis. When they have the same basis. Let's look at another interesting log. Then we say that log of a base a will give you 1. Log of a base a will give you 1. So let's see. We say that log of 10 base 10 will give you 1.